শুভেচ্ছা দর্শক সকলকে আমন্ত্রণ জানাচ্ছি প্ল্যানেটারি হেলথ একাডেমির সুরক্ষায় প্রতিদিনের আজকের এই বিশেষ আয়োজনে। আমরা এই অনুষ্ঠানে অনেক বিজ্ঞানী অনেক চিকিৎসককে আমন্ত্রণ জানিয়েছি, অনেকের কাছ থেকে তাদের চিকিৎসা সংক্রান্ত অভিজ্ঞতা জ্ঞানের তথ্য আমরা শুনেছি, কিন্তু আজকে আমরা ভীষণ আনন্দিত এমন একজন অতিথিকে পেয়েছি যিনি সারা বিশ্বে তার গবেষণা কর্মের জন্য পরিচিত এবং স্বীকৃত। তিনি কেবল নিজের গবেষণায় মগ্ন থাকেননি, তিনি গবেষণাকে ছড়িয়ে দিয়েছেন সারা পৃথিবীতে এবং আমাদের চোখের সামনে যেই গবেষণাগুলো আমরা এখন দেখছি, যে আবিষ্কারগুলো পৃথিবীকে বদলে দিয়েছে, সেসব গবেষণা তিনি কেবল পর্যবেক্ষণ করেননি, তার সাথে সরাসরি যুক্ত ছিলেন। আজকে আমরা স্টুডিওতে আমন্ত্রণ জানাচ্ছি যুক্তরাজ্যের বিশ্বখ্যাত অক্সফোর্ড বিশ্ববিদ্যালয়ের এমিরেটাস প্রফেসর স্যার ওয়াল্টার বডমারকে। তিনি ফেলো রয়্যাল একাডেমি অফ সায়েন্সেস এবং তিনি হেড ক্যান্সার অ্যান্ড ইমিউনোজেনেটিক্স ল্যাব অনকোলজি বিভাগ অক্সফোর্ড বিশ্ববিদ্যালয়। এর বাইরেও তার অনেকগুলো পরিচয় আছে, সেগুলো আমাদের কথা প্রসঙ্গে আসবে। স্যার ওয়াল্টার বডমার, ওয়েলকাম টু আওয়ার প্রোগ্রাম।
Pleased to be here.
We are extremely lucky and we feel privileged to have you here in this program. The very first question to you will be, in front of you, throughout your life, you have seen a lot of progress in sciences, and you were not just a mere observer, you actively participated and you led some of those major science projects that shaped the world. Standing at this point, how do you see the progresses of science so far, and where do you think we are heading to?
I think there are two aspects of that. There have been major advances in understanding that come from the Genome Project, understanding our genome, and that come from improved technologies that have led us to understand a great deal, improved approaches to vaccination and so on, potentially improved treatments. And there have been great advances in that respect. But that has to be balanced against the fact that there are many problems with healthcare. There are problems of providing adequate healthcare to every individual in a society. Even in the UK, where I come from, there are a lot of disparities of health in different ways. There are problems because of the aging society, that we have many more older people than before. The age structure has changed. Older people have more diseases. They have together combinations of diseases. They're difficult to deal with. That becomes expensive, so that increases the requirement for healthcare. And in many places, and I know it's true in the UK, there's a huge need in a way for more adequate healthcare, applying what we know, let alone finding out new things. So I think there are two very different areas. They're the basic science, what we can understand, what we know we should be able to do, and then the implementation of it. And some very straightforward things in healthcare.
Yeah.
If you think about cancer, which is what I've been mainly involved in, you obviously want to try and prevent it. The best way to prevent is to stop people smoking. Now, that's not an area of research that needs more work. It's a social problem. It's a political problem. How do you promote the need that you shouldn't smoke? How do you control it? Do you increase taxation? Do you limit the age at which you're allowed to smoke? All of these problems. So there are two very different aspects, and they're somewhat disparate because we can be very far forward with treatments and yet only apply them to a limited number of people because of costs and so on.
Okay, so it means that although we have made lots of progresses regarding scientific discoveries and breakthroughs, but to actually mitigate the challenges and to solve the existing problems, we also need social and political interventions, and to make, for example, the equal access to healthcare services, then we need different other programs where participations are needed from different organizations, including states and social organizations that are active in the scene. So if we want to do that, if we really want to make good progresses and, for example, universal health coverage, or people get basic health services, what type of policies the government or international organizations, for example, World Health Organizations, those players can play?
Well, I think governments have a problem. Healthcare, and I think of the UK, we have a National Health Service, which in principle provides care for everybody, and I'm a strong believer in that, and it's needed. But it's very expensive, and how do you balance the expense needs? How do you find enough doctors? It takes, 5 to 10 years, at least 10 years really, to fully train a senior consultant, as we call it, a person who's qualified at a high level for dealing with surgery or cancer treatment or any aspect of it. So I think that there are fundamental problems that are much discussed. There are also issues of making people aware of what they should be doing. And smoking, of course, is one and a good example. Obesity is another, probably international problem. But these things, of course, are very different in different countries, different age structures, and different systems for providing health care, and so on. So I think there's a lot of thought needed to be given to the nature of the way health care is organized, and it can be quite different in different countries. For example, in the UK, we have family doctors, general practitioners, which are your first port of call, as we say, the first place you go to. And they are very busy, and yet they are the main filter for deciding, well, is it likely you've got a cancer? Is it likely you need an operation of some sort? Or what is it that you need to have done to you? And that's very important. And I think it's a very good system, because then they can lead you to the more specialist side. But not every country does that. Yeah. So I think countries have to adjust to some extent. But undoubtedly healthcare is a major issue for every country that wants to do anything sensible for their population's health.
Yeah, exactly. I want to move away from this general discussion. I want to move to the scientific part of it, because as I said in the beginning, that you were actively involved with all the major activities that has happened in fact in last almost 50 years. In your considerations, what is the major breakthrough that happened in healthcare research and science in last 50 years?
I'm a person that doesn't like breakthroughs. I think they're advances.
Yeah.
But if you really look at it, the one major breakthrough is undoubtedly our understanding of the basic processes of inheritance, the way genetics works, as we say. We know that DNA is the language of life in that way, the discovery by Watson and Crick of the structure, and teaching us how, therefore, DNA is replicated and how it works, how it leads to products. I think that if there is a revolution in my lifetime, that certainly was it. And it started at a time just when I was beginning to be a student in Cambridge, which in England, where the Watson-Crick structure was found. But then there have been many other advances. I mean, the advances in knowing the structure of proteins, the advances in machinery that can, scanners of one sort or another, MRI scanners and so on, have been hugely developed and of course are very important. I think surgery, even the development of semi-automated surgery is an important area. So I think there have been absolutely key advances in that way. But if you go into detail, you'd have to start talking about particular treatments and so on. But I think that's probably the most important underlying change, that nothing now can be done without in some way referring to what we know about our genome.
Okay. So in that aspect, you consider the Human Genome Project that took place in the last decade of 20th century. And you were also one of the major proponents of Human Genome Project, actively took part in that. Can you shed some light on that project, how that has delivered so far?
Well, once it was known that the language of life, if you will, is the sequence of the DNA. It's 4 letters, it's a 4-letter sequence, but there's a huge amount of it. And so there are something like 3 billion letters worth of information. And once that was known, it eventually became clear that we would gain a lot of benefit from knowing the complete sequence of the human genome, which was a huge task. And it began to be suggested, and I was very much involved in that, probably around the beginning of the 1980s. And there were various meetings and promotion of the idea that one should have that as a major project. There was a lot of opposition because people thought it was big science, eating up lots of money for the poor, lesser mortals who were doing small experiments which they thought were important. But there was a remarkable, in the end, international consensus that this was a good project. And at that time, sequencing one sequence with the technology that was then available was foreseen to cost $2 or $3 billion, which at that time was probably several times what it is now, but still compared to national expenditure, it's not huge. I mean, it cost you that much to design a few rockets, for example. But it was a very interesting development that there was international consensus. It was driven particularly by the United States and the UK, but it involved countries throughout the world. There was an agreement that as the sequencing developed, the sequences would be made publicly available. There was an agreement that there should be a need to monitor whether there were any problems connected with unknowing the sequence. And I think altogether it was a remarkable example of international collaboration between scientists in different countries that led eventually, there was a big fuss, and two of our Prime Minister and the then President came out and said, we've done it all in about 2000, which is something I'd suggested might be possible, whereas in fact it wasn't for several years more until we finally had the complete sequence. But the astonishing thing is that with that, since that time, has come this ability technologically so that a sequencing of a whole genome now is a few $100, not a few billion.
Yeah, exactly.
And that's an extraordinary development which is dependent a lot on computing, but also on the technology of the way that the sequencing is done. And it was not just the human sequence.
Exactly.
Because everybody said, oh, well, you know, how important is it really? And you had to explain that if we knew the human sequence, then we could often say, what's the genetic inherited basis for disease? Cancer is a disease of genetics of the cells. There's almost anything you want to discuss feeds back into that, but of course depends on a lot of other work. So I think it was a remarkable achievement, and there continues to be, partly I think through that development, very good collaboration on basic science of this sort, which I think is extremely important. Science is the same whether it's done in China, in Bangladesh, in the UK or anywhere else, and it's extremely important that scientists collaborate and work together, and that there isn't any feeling that there's a science that's different for one type of person or another.
And thank you. I think that's a very pretty amazing interpretation, and also from your personal experience and involvement, you have shed light on the amazing achievement that's been made, especially in the Human Genome Project. And as you mentioned, it's not only just human genome. Since then, we have sequenced lots of other genomes, and we have probably found one of the best examples and usefulness of the sequencing ability during the last pandemic, like during COVID pandemic, when the thousands of genomes became sequenced in a short period of time, and that helped a lot to generate some of the vaccines that we have found in a quickest time frame.
What you say is of course important, that the first sequence was of a virus. And Fred Sanger, who's very famous for getting 2 Nobel Prizes, one for how you sequence proteins that have these letters of sequence that define the structure of a protein, and the other for a technique for sequencing DNA. And I remember hearing his lecture on a small virus that was the first thing that was sequenced. And then you get to a worm that's been widely used for genetics as a model for what can go on, C. elegans, that was introduced by Sidney Brenner, who later got a Nobel Prize with others for what you can do with that worm. So there were a lot of things like that, and if one thinks now, think how quickly the virus that was connected with COVID-19 pandemic was sequenced. That was an enormous use because you could sequence those quickly. You could find out what new variants came along, how you might deal with them. There are so many areas where, and nowadays, just the interest in the relationship between species and evolution. There are programs to try and sequence some DNAs from nearly all species, which is a big task, but it can tell you an enormous amount about how we evolved, and that's interesting and possibly very important to know.
Thank you, Sir Walter. We have heard quite a bit about some of the developments that took place in the last 50, 70 years, but you are also very actively involved with lots of development. But I think before going to that part, I would love to know, how did you end up into this research, like genome cancer research and also human genetics, all these things, how it came to your life?
Well, it started with mathematics. When I was at school, I could do sums quite well, and I was quite good at maths, and someone said, well, that's a useful thing to study, and I enjoyed it. So I studied maths in Cambridge, which was an outstanding place to go with. And during the first 2 years of what, in my case, could be a third year where you did other courses in the third year, I had a lecture course from a very well-known, sadly recently died statistician, Sir David Cox, who gave a sort of survey of statistics. Now, statistics is how you analyze data, how you deal with data, and I found that very interesting, and had decided I might like to be a statistician. And he said to me, well, in Cambridge there's this man called Sir Ronald Fisher. Now, Fisher was one of the most remarkable scientists of the 20th century. He was the founder of modern statistics. He was the person who took how we understand genetics as it was described by Mendel and reconciled that with the evolution by natural selection in the subject called population genetics with a lot of mathematical background. So I went to his lectures. Now at school I'd learned no biology effectively, which I think was a wrong thing. You shouldn't have that narrow an education, although I was fortunate in my case that it didn't in the end prevent me from doing interesting things in biology. So before I went to his courses, I had to learn about genetics. So I read a genetics textbook, and I read some of his quite difficult texts. And I was fascinated. It seemed to me here was something new and different that had an element of the mathematical side to it, and that's what I wanted to do. So within 2 or 3 months of starting his lectures, I went to him and I said, would you take me on as a student? And he did. And it was strange because he was so outstanding, and in a way an outstanding mathematician as well as an understanding of biology, that he hardly had any mathematicians who went to work for him in Cambridge. So that was really my starting point, and it was a remarkable starting point because he was a mentor of incomparable quality and knowledge. So I did a PhD in statistical and population genetics. I did a few experiments with primroses and how they self-fertilize and so on. And then at that time, when I started my undergraduate time, was the year that Watson-Crick discovered the structure of DNA, and Jim Watson was in the Cambridge College, Clare, where I later was. And I was more or less told by the professor of genetics, Professor Thoday, who'd succeeded Fisher, well, maybe you should learn about molecular biology. And I thought that was a good idea. Go west, young man, to the United States. And actually, Francis Crick, who I'd come to know because he was a friend of Fisher, suggested someone I go and work with in a very well-known scientist, Max Delbruck. And I didn't get that scholarship that would have got me there. And it's one of the examples where a failure to do something was actually a huge help for me. Because then I decided I was going to pick my own person to go. And at that time, Joshua Lederberg, who was my second major mentor, an outstanding geneticist, won the Nobel Prize for showing how you could do with genetics with bacteria, with E. coli, which underlies what genetic engineering is. And I wrote to him and said, would you take me on? And at first he said, no, I don't think I can, and you should go and work with someone in Caltech. So I wrote back to him and said, no, I want to work with you. If you can't take me next year, take me the year after.
Yeah.
Important to be persistent.
Yeah.
And he wrote back in his own handwriting, dear Bodmer, your persistence is flattering.
Okay.
From a Nobel Prize winner to a young guy. Anyway, that's the beginning of it. And it was through that, and he was another remarkable mentor, not only genetics, he was a founder in some ways of aspects of AI and expert systems. He was an extraordinary individual. And so that was a marvelous experience, and it did teach me about molecular genetics. I was at Stanford University, which was just then becoming, on its way to becoming the outstanding university it is now, and gave me an opportunity to develop my own interests. And it's there that two of the major features of my early work were initiated. One was how you could do genetics with cells in culture, human genetics, that parallel what you might be able to do with family studies. And the other was the involvement in the discovery of the system of genetic differences that makes it impossible to do a graft from one person to another, because we all differ sufficiently genetically that our immune system, which is meant to recognize infections that are different, recognizes the difference between you and me, and then would reject a piece of skin that you put on my skin. And so I got involved in that area, which was a major, an interesting area that I subsequently took a major interest in. So that's what took me into the direction of really working on human genetics and problems with a mixture of the laboratory work and where it was relevant, understanding the statistics and how you could do mathematical models that might be relevant.
No, amazing. I think for the sake of the Bengali audience, I would like to highlight two things for them, and then I will come back to you with another question. So, দর্শক আমরা যে উত্তরটি শুনছিলাম স্যার ওয়াল্টার বডমারের কাছ থেকে, তিনি আমরা যাদের নাম সাধারণত টেক্সট বইতে পড়ি, আর এ ফিশার, যার নামে ফিশার টেস্ট নামে একটি স্ট্যাটিস্টিক্যাল টেস্ট অনেকেই আমরা ব্যবহার করি, তার পিএইচডি স্টুডেন্ট ছিলেন স্যার ওয়াল্টার বডমার। এবং আমরা জেনেটিক্স যেই বিষয়টি আছে এবং জেনেটিক ইঞ্জিনিয়ারিং যেই বিষয়টি আছে, সর্বাধুনিক যেই বায়োলজির বিষয়, তার একেবারেই অগ্রগণ্য বিজ্ঞানী যিনি জোশুয়া লিডারবার্গ, স্ট্যানফোর্ড ইউনিভার্সিটি, তার অধীনে তিনি পোস্ট ডক করেছেন। এবং এদের সান্নিধ্যে থেকে তিনি দুটো জিনিস খুব হাইলাইট করেছেন। একটি হলো ব্যর্থতা, অর্থাৎ ফেইলার যেটা, সেটা কখনো কখনো একটি জায়গায় ফেল করলেও অন্য জায়গায় অন্য নতুন দ্বার উন্মুক্ত হতে পারে। এবং আরেকটি গুরুত্বপূর্ণ বলেছেন যে পারসিস্টেন্ট থাকা, অর্থাৎ কোনো জায়গায় যদি আমি সত্যিকার অর্থেই যেতে চাই, তাহলে সেটার জন্য আমাকে খুব দৃঢ় প্রতিজ্ঞ হয়ে কাজ করতে হবে। এই বিষয়টি তিনি অত্যন্ত গুরুত্ব দিয়ে তুলে ধরেছেন এবং তার ব্যক্তিগত অর্জনের কথা বলেছেন। স্যার ওয়াল্টার, the next I think it will be very interesting to learn about your involvement in cancer research. How did you get interested into this field, and how do you see cancer as a disease?
Well, the way I got involved is there were two major cancer charities in the UK. The charities play a big role in cancer research. They raise money from the public, and one of them was called the Imperial Cancer Research Fund, and they were looking for a new scientific director. And they came to me, and I was a bit surprised, but they came, I suppose, because already it was being realized that genetics was an important part of understanding how cancer worked. So they asked me to take the job, and it was a better job and a challenging one. And rather like the genetics, I didn't know much about cancer, so I had to read up and take textbooks. So that's what got me into cancer. And it was a major opportunity, really, because my predecessor had been a very distinguished scientist, Michael Stoker, and he'd already developed an appreciation of the need, for example, for molecular biology, for sequencing, for these technologies in cancer. So I was able to build on that. And I had the responsibility, of course, for all aspects of cancer, including the clinical research, clinical trials, all the way down to the most basic research you could do to understand how things work. And I decided for my own research I wanted to continue, because I think if you're leading a research organization, you should lead from the front, so you should show that you could also yourself do the sort of research that you want other people to do. So that's how I got involved in studying the genetics, the inheritance of colorectal cancer, and that was very important for me. But there were many other aspects. It was a challenging job. We built up clinical activities. We developed genetic counseling, small centers throughout the country and so on. So it was not only doing my own research, it was not only a central research laboratory, but also going out into other parts of the country where there was good work going on in the cancer field, and at both the basic and the application level, if you will.
Okay, so it means that it's not only doing research by yourself, but you also promoted research and also science in general in UK quite extensively. And if I remember correctly, your outreach activities and also policy that you suggested for popularization of science among general people, it ended up being a report which is called Bodmer report. So if you shed some light on that, like how did it shape the scene in UK?
The Bodmer report was on the public understanding of science.
Yeah.
Now one talks about public engagement. And I had become, from quite an early stage, interested. In fact, even as a young graduate and research fellow in my college in Cambridge, we had a society where you talked about what you were doing and tried to explain it in a way that was understandable. My mentor at Stanford University, Joshua Lederberg, was very active in this. I had already become involved in the areas of explaining things. And I got caught more and more into that. I gave, the sort of programs we're talking about on the radio in '73. I remember one program all about vaccination, just the same problems one has now. So because I'd got that sort of involvement, I'd also been on a BBC advisory committee advising on science in the BBC's programs. So the Royal Society, in its wisdom, and it was a very good thing, said, well, in addition to promoting the teaching of science in schools, which is where it all should start, there is a need to bring the meaning of science to the general public, to show them what can be done, to try and explain things so that they can understand it. And I was asked to chair a committee, one of whose members was the very famous Sir David Attenborough, amongst others, that should report on the public understanding of science. And we produced a report in 1985, which in the end, in the UK, was extremely influential, I have to say. It led to much more activity in those areas, the feeling that, every scientist shouldn't become that as a major thing, but should make some effort to explain in ways that the general public can understand, who are not specialists. It became a requirement of every research grant that you say something about what you're going to do for public understanding and public engagement in scientific affairs. It led to a book prize, for instance. So it actually, and it also led to courses which we had at my own institution that were helped by my predecessor to try and help young scientists, especially graduate students and postdoctoral fellows, to do a bit of understanding. And we also took our senior faculty and gave them, examples of how to practice it, to get out of a motor car, face some questions that said, well, why are you doing all these animal experiments?
Yeah.
I remember in a program on the BBC with a very well-known interviewer who we discussed everything, what to do and what I was going to answer. And all of a sudden, in the middle of it, she said, well, why would you want to do this with making a new frog with something? Okay. And that's what got the Nobel Prize, and is the development of many abilities to understand the early development of the embryo. So I have enjoyed that. I've kept up an interest. I don't do as much as I did before, but I always felt it was very important to have a good relationship with the journalists.
Yeah.
And in the time when I was in charge of the ICRF, I had a very good person helping me in this, and we made it our business to get to know all the best journalists in the major newspapers, particularly, of course, in the medical area, but in general in science. And I think that's very important, that communication. And I'm not sure it works as well now as it should do. I think it's very important. And you could just see during the pandemic how important it was to explain to people what was going on.
Yeah, it's true. So this public understanding of science and promoting this kind of activity is very crucial, and scientists should take lead into these projects. And
there's nobody else who knows what's going on at the forefront except the scientists.
Exactly. So they should
have the job of explaining what it is they're doing in ways that people can understand. Which is very, very important.
Yeah. So in regard to this this aspect of your work and life activities, I can extend that your activities were not only limited in UK, but you also have extended your hand to different other countries too. You went to different places and helped different countries to set their policies, especially to strengthen their scientific capacity. So I would like to draw your attention to Bangladesh. This is for the second time you are visiting. You first came just before the pandemic, or we can say in the beginning of pandemic in 2020, and after 4 years you're back again. What have you seen in Bangladesh? Is there?
Well, I say this to everybody to start with. You tend to learn about a country from what you read in newspapers and see. And it's always catastrophes. There's a flood, there's someone murdered, there's something happened, the politics is wrong. And that doesn't really give you a picture of a country. You only learn about it when you go there and see it. And I have to say, when I first came through your kind invitation 4 years ago, just before the pandemic, I was very impressed that Bangladesh was not at all what I thought it would be. It seemed a lively country, friendly, trying to move ahead in ways that I don't think many of my friends and colleagues in the UK would realise. And that impression has been reinforced by my current visit, chance to speak to many people, to see what's going on, and to see what tremendous efforts there are really to move forward for the country. There's still a lot that can and needs to be done. In my view, develop much more research in the main universities, the public universities, because it is the universities where research discoveries are usually made. And of course you can say, why do we need to do the research that's done in the UK or the USA? The answer is, if you don't have your own research at the forefront, you won't understand what's coming. So it's not only that you can contribute, but you can implement what comes from the new research to the benefit of your country, and I think that's very important.
So I think this will be probably the last question to you. From your experience so far in Bangladesh, the enthusiasm that you have seen, the prospect within the country, what will be your suggestion to the government and also for the other organizations who have the capacity to influence the direction of our research, health research in the future?
I think one of my suggestions would be that there should be much more emphasis on supporting research in universities. Research and teaching go together. And most of the major discoveries we talk about have been made either in university research departments or like the very famous laboratory for molecular biology in Cambridge, which was based in Cambridge because it is an outstanding environment for research. So I think that's extremely important, together with the support for high quality education that goes not only for the undergraduate level, but also allows people sometimes to do their PhDs here and not always have to go to Japan or to England or to the United States, although that can of course be a benefit when people come back here. So I think that's the one thing that struck me particularly here, that there is a need to develop that. There's a potential interest, and I've been to, as you know, 1 or 2 universities or more, and you see a lot of enthusiasm there, and I think that should be taken advantage of by providing the resources that are needed for first-class teaching and first-class research together.
In Bangladesh. Thank you so much, Sir Walter Bodmer. It was a pleasure to listen to you and also for your visit to Bangladesh and giving us time for this interview.
It's been my pleasure to come here because of you.
Thank you. It's my pleasure and my honor. দর্শক, আমরা শেষ করছি স্যার ওয়াল্টার বডমারের সাথে এই চমৎকার আলোচনাটি। শেষের দিকে আমরা বাংলাদেশের প্রসঙ্গে কথা বলেছি। তিনি অত্যন্ত ইতিবাচক ধারণা রাখেন বাংলাদেশ সম্বন্ধে এবং বলেছেন যে বাংলাদেশে আসার আগে তার যে ধারণাটি ছিল সেটি কিন্তু তার ভেঙে গিয়েছিল সেই 2020 সালে, এবং এই যে এখন যে আবার ফেরত এসলেন 2024 সালে, এটি আবার নতুন করে আরও ইতিবাচক ধারণা তিনি নিয়েছেন। এবং আমরা দেখেছি ব্যক্তিগত আলোচনায় বাংলাদেশের সাম্প্রতিক অগ্রগতি, আমাদের ইনফ্রাস্ট্রাকচার যেসব ডেভেলপমেন্ট হয়েছে সেগুলো কিন্তু তিনি অত্যন্ত আগ্রহ ভরে প্রশংসার দৃষ্টিতে দেখেছেন। কিন্তু আমাদের এগিয়ে যাওয়ার জন্য বিশেষ করে সরকারি উদ্যোগে আমাদের বিশ্ববিদ্যালয়ে গবেষণা বাড়ানোর ক্ষেত্রে তিনি গুরুত্ব দিয়েছেন। আশা করি তার যে কথাগুলো, তার এতদিনের অভিজ্ঞতা, 88 বছর বয়স তার এই মুহূর্তে, এবং শুরুতেই যেটা বলেছি যে অনেক আবিষ্কার তার নিজের হাতে হয়েছে অথবা তিনি তার সাথে সরাসরি সংযুক্ত ছিলেন। আশা করি তার এই অভিজ্ঞতালব্ধ যে জ্ঞান, সেখান থেকে আমাদের যারা সিদ্ধান্ত গ্রহণ করেন তারা অনেক কিছু নেবেন এবং সেগুলো বাংলাদেশে পালন করার চেষ্টা করবেন, এবং এইভাবেই আমাদের দেশ এগিয়ে যাবে সমৃদ্ধির পানে। এই আশাবাদ রেখে আজকের মতো শেষ করছি সুরক্ষায় প্রতিদিন।